California desalination plant, 50 million gallons a day. And all the things we're talking about, all the issues are relevant. And then Santa Barbara, a much smaller facility, two completely different construction models, by the way. One was so-called stick-built, where everything goes to the site and then you build it. And the other, Santa Barbara, was built in modular fashion, where it was built in a factory and then shipped on the back of a truck and put together sort of like Legos. Both pretty significant projects in California, given California desalination politics, which I want to talk about a little bit. And I chose at the end of that to leave the big desalination space because I didn't have much confidence that we were ever going to build another one. And if you are familiar with what's going on in California politics, the Huntington Beach one got denied about a month and a half ago. However, the Doheny Beach one got approved, and we can go into the boring detail as to why, but I'm rejuvenated again. And in the meantime, I serve as a mentor to a company, an entity called Imagine H2O. Imagine H2O is San Francisco based. We look at, it's an incubator accelerator company, and we look at exclusively water technology companies, early commercial stage, and try and help them get up and running. And I've done, I suppose, 8 or 10 mentorships, one of which I'm going to talk about today. And that's not why I brought it. I brought it because of the potential for this to become a key piece of the portfolio for California, specifically in the desalination space. So I'll start off by saying I love the desalination space. I also am a big fan of recycle and reuse. 30 plus year water guy, started way back when Dick Heckman founded US Filter. And I have some friends and colleagues here in the room that I've worked with over the years. And so let me introduce this company called Oneka. They're Canadian based. They went through the, how do I accelerate just the red button? They went through the Imagine H2O process, and I was their mentor, and I quite like what they're doing. They are taking, we've heard of buoy-based electricity generation. There's a handful of companies that are doing it quite successfully, although none of them have really reached scale yet. Oneka is a mechanical wave-powered direct desalination technology. So the buoy that you see generates desalinated water using reverse osmosis in situ, I'll say it, meaning within the wave profile, it makes its own water and pushes that water to shore. I won't bore you with all this. It's a wave actuated system. It does use reverse osmosis. We've been talking about this. The theme has been all day, it seems like, reverse osmosis. And you could imagine, in order to scale up water, you would put an array of these buoys out in the ocean. How far out in the ocean? In the wave profile. So what they want, or what we want, is 2 to 3 to 4 foot wave profile. So you can go up and down any coast in the globe, essentially, and look for wave profile of that, and you will make desalinated water. We'll talk about how much here in a bit. Zero energy input. It's truly the wave power that generates the thing. And if you saw some of the slides earlier, and I'll quote for fact, 50% of the cost of water at Carlsbad is electricity. So the so-called $6 a 1,000 gallon water that we quote, which by the way is quite cheap, half of that is the electricity consumption. And if you took that away, it would be about $3. This can make water for under $2 a 1,000 gallons. So the capital cost is very small. It's a floating buoy. There's not all the pretreatment that we just talked about. Here's what one looks like. They tested it in the North Sea, actually off the coast of Nova Scotia and in the North Sea. And this is just a couple of the guys in pretty harsh environments to make sure that the thing didn't fall apart. The 2 guys were cold, but the equipment lasted for quite a long time. I think they were in there for 6 months or something. And this is when they were still in their sort of demonstration, early commercial stage, when all the companies are looking for funding, when companies are looking at how to talk to customers, when companies are looking at how to grow their business from zero to something. And so they've done this successfully. They've been around for maybe 6 years. It was university developed. The founder and CEO is quite a good guy. And by the way, I said 3 to 4 foot wave profile. It'll work in 30-foot waves, but don't need to go that far out. It'll work in harsh environments. Three kind of sizes that they have developed. This small scale so-called ice cube is for piloting purposes. If a community would want to prove that it works offshore of their community, you could do something like this. It's very low. In fact, there's zero capital equipment. The business model for the company is water as a service, so you don't buy anything except water. That's just a business model. I won't claim it was my idea, but I was very supportive. Why have a community pay for CapEx and then OpEx and then buy water? Let's just sell them water. So 250 gallons a day, not very much, but proof of principle. The unit that we saw the picture of previously is this iceberg unit, which is less than 500,000 gallons a day, not per buoy, but an array of buoys. And then we could go up as high as 2 to 3 million gallons a day, which would solve quite a bit of the problem in coastal California. And let me backtrack just a minute. It's my opinion, it's only my opinion, that we will never build another Carlsbad. I don't think 50 or 100 million gallon a day facilities will happen in California anytime soon. Instead, what we talk about in our industry is small distributed assets, meaning close to the customer. So smaller scale volumes of water, smaller scale volumes of wastewater treated. And the same goes for seawater desalination, small plants that produce 2 to 3 to 4 to 5 million gallons a day and serve a small community, kind of like what Santa Barbara was. And that's the intent here, is that these buoys could be distributed up and down the coast. I'll use California because that's where we are, and I have a case study for you. But it turns out they are making water for this small gated community off the coast of Florida called Ocean Village. I can't remember it's 300 cubic meters a day, so that's 75,000 gallons a day, and that was enough to fill the gap from their challenged situation. They didn't have enough water, so an array of these buoys provides all of the supplemental water, if you will, for Ocean Village. My friend Orlando Correno was here and spent a lot of time in Chile. They just deployed a unit in Chile off the coast of Antofagasta, which we all know, love, and well. It's 13,000 gallons a day. The buoy is there and operating and producing water for an end-use customer, an off-taker. So those are the two sort of flagship installations so far, but again, small, but real. And the one I want to talk about, so how many have ever been to Mendocino County in Northern California, wine country? Tell me when you went there, it didn't rain. It always rains in Mendocino County. Well, guess what? Not anymore. Mendocino County is one of the counties in California that is one of the worst drought counties we have in the state. Surprise, surprise. And they rely on surface water from rivers, and the rivers are dry in September and October. And so while they have surface water and some limited groundwater sources of water, in the city of Fort Bragg happens to be sort of the focal point of the Mendocino problem. It's a coastal community. I should have said that. You've probably been there. They don't have enough water, and small communities like Mendocino Town truck water from Ukiah, which is 75 miles away. They pay 15 cents a gallon for water to be trucked in 5,000 gallon tankers, and several trucks per day deliver water to Mendocino Town so that the restaurants or the coffee shops can stay open and serve tourism. That's simply their need for the water. So we have been actively involved with the city of Fort Bragg, who, as a side note, is reinventing itself and relevant for here as a blue economy town. They're going to revolutionize their entire community to become a blue economy. Fishing has kind of gone by the wayside, and it was a lumber town and a sawmill, and now they're going to be based on the ocean. And as part of that, they need water. So ONECA has established a partnership with the city of Fort Bragg, and the city of Fort Bragg will highly likely be the first place that we demonstrate this buoy in California. It will make 15,000 gallons a day of water as a demonstration. And for those who are interested in what is the Coastal Commission going to say, who are the ones we like to wish would go away, there's a couple of issues here. One is This falls under the 0.1 million gallons a day pilot requirement. So if you're less than 1.1 MGD, so 100,000 gallons a day, if you're less than that, you can fall under an emergency parameter to demonstrate new technology. That checks that box. A lot of people who are familiar with ocean desal will ask, what about the intake and outfall issues associated with land-based plants and the entrainment and entrenchment of fish? This buoy operates at about 15% recovery with very small intake velocities or very low intake velocities and a very small screen. So there is no entrainment and impingement. And the buoys are going to be placed actually out about right here, about 100 meters, I think it is, offshore, and the water will be pumped to a tank that is very, very close to a piece of land that the city of Fort Bragg owns, and then that water will be then added into the distribution system. So we've had preliminary meetings with the Department of Water Resources, with California Coastal Commission is aware. This is probably going to take a couple of years before there's an array of those buoys providing water, but we think by spring of next year, a deployment buoy, a development buoy will be in Fort Bragg producing water for the city of Fort Bragg. And I'm pretty excited about it, as you can tell. That's it. That's my presentation. Again, desalination is here to stay. Let's find ways to make it better, cheaper, and faster. That's me.
Okay, Mark. Our next speaker this afternoon is Yuliana Mendoza. We've heard Yuliana earlier today asking some questions. She's one water practice leader for Garver. Yuliana worked 20 years with the Bureau of Reclamation, leading strategic planning and management of the waste treatment research programs. Did you work with the WQIC? Were you part of WQIC in Yuma, or did you have anything to do with that? I worked with Yuma, yeah. Okay. And you joined Garver recently to help clients and communities using innovative techniques to address water challenges. And she's got degrees in chem engineering, environmental science, and technological commercialization. So, Yuliana?
Yes, thank you. That's okay.
No worries.
Okay, so I'll be talking about a case study that Garver did on electrocoagulation. That's the technology that they've been using. So that hence the electrification concept for desal. And obviously Eric Dole is the one that did all this work, and I'm just here to kind of present this for you since he couldn't make it. Bureau of Reclamation did fund this work when I was in Bureau of Reclamation, which is why he trusted me to deliver the presentation. Otherwise, I think he would have picked someone else. So the problem is really focusing on cooling towers and the blowdown from cooling towers, taking in that water and reusing it by treating it. And obviously trying to solve the problem of salt accumulation that accumulates when you have cooling tower blowdown water, and not allowing that water to go into the sewer sheds, which then ends up in your wastewater. So really that was the focus in the power generation sector for cooling water. As you look at kind of how water goes all around the circle, if you could remove those salts, then you don't reintroduce those salts back into the water system, in this case, into the wastewater. Okay, so the solution, the treatment train. What is it that Garver put together to look at this? They partner with Red Rocks Community College in Colorado to start looking at their cooling tower. That is where their pilot was set up and put together. And it's really looking at like a small pilot system to look at all of their cooling tower blowdown. It's really the contributor to salt in the watershed there in Colorado. And they're looking at collecting that, treating it through a system of electrocoagulation and filtration before RO. And then using that concentrate from the RO for potential zero liquid discharge, basically through a VAED system, which is a vacuum assisted electro system. So the electrocoagulation and the clarification unit process is really hitting the water from the cool down once you collect it, getting it through an EC system to be able to remove all of the constituents that are in that water that would basically scale up your RO. And that electrocoagulation basically is your pre-treatment for your RO system. So the goal of the research was to improve the process efficiency and the energy efficiency for RO with the use of electrocoagulation as a pretreatment. It precipitated basically pretty well, actually. A lot of the suspended solids, the heavy metals, the bacteria, viruses, algae, silica, hardness, boron, and a lot of other contaminants. There was different case studies at the bench scale that was done with electrocoagulation before this pilot to collect the data that this was a viable technology to use before RO. It really helps to prolong the life of that RO. I think there hasn't been any cleans on that RO unit since it started operating in late 2019. So it's been running for about on and off 2 years. And I don't think there's done any cleaning on that RO since the system's been running. So it's been doing actually pretty good. This is what the little EC system at the pilot level looks. This is just a simple filter for the water before it hits the electrocoagulation system. It does very well removing total suspended solids, heavy metals. There was some wastewater work that was done that had some oils, bacteria, and other contaminants from the water. It's actually pretty efficient chemical coagulation in a way. Charged contaminants are magnetically attracted to the anode side of the electrocoagulation, and then charged contaminants are also on the cathode side. So that's the unique thing with electrocoagulation. You have that charge within it. It's also polarity reversal every minute so that it prevents any plating within your plates that you have in your electrocoagulation. So it does pretty good. It is actually a pretty good running unit for EC. It is an alternative to traditional chemical coagulation that you would do as a pretreatment. So it's actually a way smaller system that you could use in terms of pretreatment instead of doing chemical coagulation, as well as not as energy intensive. This is a case study at a wastewater demonstration. So this is a little bench scale system that Eric travels with in a little case everywhere he goes, where he wants to do a test. And really, he needs just a water sample. He can run the EC system quite well. You could see very, very quickly the filtrate on the middle over there is the 11 micron gravity filtrate control. So if you just kind of pass it through a filter, you get like this little grayer area back here. And then if you run it through the EC, you get a little clearer water in terms of the filtrate that you get after EC. Let's see what other things he put in here. There. So the membrane fouling constituents are very challenging for RO. So if EC could potentially, and we have shown in a lot of the testing that has been done, can reduce this membrane fouling constituents in a lot of various type of waters. Cooling blowdown water is challenging, and wastewater as well is actually pretty challenging. Some of the highlights in terms of the lab results of the different raw water that was put together. Oh, there it is. You can see in the bottom all the different constituents that were measured in terms of the clarifier, and then what the EC unit was able to do. He ran it 2 different ways, just the electrocoagulation, which is that blue line, as well as with Fenton, which is just an oxidative process. And you could actually remove silica, total phosphorus quite well with the EC system, both the regular EC and just with the Fenton, and pretty successfully in terms of all of the different constituents that would cause you a problem in your RO if you don't remove those systems. So a 5-log removal of fecal was achieved, and Class A solids with the E-Fenton process was also achieved. After it goes through the EC system, you basically have a filtration system so you can remove the flock that carries over. They used actually a microfiltration system. The idea was to use UF, but not a lot of very small UF systems are available for pilot scale, especially at this size. So MF was used instead. It was really well put together. It reduced the scaling potential through 95% removal of hardness, silica, and phosphorus. It achieved 3 to 5 log removal of virus, bacteria, and algae. It increased recovery 10 to 30% for the RO, which is huge for an RO system. And the solids accumulated on the cartridge filters, and you could literally just rinse those cartridge filters with a hose and all of it would come off. So I did see him wash those filters once. So it came off pretty quickly. The VAED system is the last step, which is your brine management aspect of it. You could basically make a cake of solids out of the vacuum-assisted electrodialysis system. This is the latest prototype. The company that builds these is called the Salt Miner, and they put the system after the RO, once you concentrate that stream, to be able to kind of recover the rest of the water out of it. It is vacuum-assisted electrodistillation, and the distillate was basically put back in the system. So the way the pilot was run was closed loop. So every water you recovered, you put back in the feed, and then you kind of continued to be able to put this together. It does combine ohmic heating with the vacuum distillation, which makes it unique in a one process to reach the temperature that you need to actually get a distillate. It's a higher TDS that you can get out of the system, and the higher your concentration, the quicker it flashes. So therefore, the more water you can get out of it. It's important to condense this as a quick flash, otherwise you kind of lose your vacuum in the system. So the higher the concentration of your water, the better the system will work. The unit they had here is 1 to 5 gallons per hour is kind of what the amount of water that was going through the system. There's a lot of challenges with temperature and kind of the materials you're using for the system. So through the pilot, they were working a lot through the materials that you're using in the system, just because how quickly this can heat up. I think he melted one. 250,000 ppm TDS is what the concentration was there, and they could distill it down to less than 500. I think they went as low as 300 ppm with the system.
I have been operating
That's Eric talking.
the VAED since October 4th, and the same brine was left in there.
So you can see the boiling on the
from
top.
here to there today. And we got a really nice distillation flow rate.
So it's a pretty neat system that didn't use a lot of power for the distillation process. And optimization still, obviously, after a pilot is needed with a system this size.
Vacuum cutting 25 inches of mercury across the cherry injector, giving about 20 psi on the chiller, the radiator, cutting about 12 degrees Fahrenheit across the radiator, assisting in the cooling of the top, maintaining 20 degrees centigrade up top. Chiller headspace.
Yeah, I don't know if you can hear him very well, but he was going through the whole process in terms of the data they were collecting. And to me, the unique part was just really looking at the system and how well it was working as it was running and kind of producing the distillate that was needed. There was a lot of partners in this work. There was a lot of help from Red Rocks Community College. The students actually were the ones that built a lot of this in the pilot unit in the trailer. They operated the system. And so there was a lot of learning along the way, which is kind of what makes pilots fun. The current status and future of the work, there was some 3D modeling done from the students as well of how you would fit all this system in a small trailer. There was a request for additional funds through NAWI, which showed a lot of interest. For those that know about NAWI, the DOE Desal Hub, it's a great place to kind of continue to push and scale up your systems. Once you have a proof of concept that you know works, you get some data. The amount of funds that they have available through their pilot now that they put out is a way for companies like Garver and others that are looking at innovative technologies to try and scale up the systems and really look at the efficiencies and how can you optimize the systems. So that's the next step for this work. This is Dr. Peter Fisk, who's the executive director of NAWI, that really loved this work. He actually went and toured the pilot that was at Red Rocks, looking at the potential for work like this. And this is the little tank, the feed tank for the cooling tower that gets collected. Obviously, you see organics in there that kind of get developed. And this was one of the tours that was done at the Red Rocks facility. So you can see how murky and ugly that water can be. The more blowdowns and more recirculation you do, the higher your concentration becomes. So with that.
Thank you, Yuliana. have to apologize to Yuliana because I introduced our company as Graver, not Garver. And for some of you who are near my age in the industry, Graver Water was a very big water company a long time ago. I don't.
figured you wanted turkey and you were thinking about gravy.
Maybe that might have been very possible. Our next speaker is Mr. David Reavley he's the CEO of Solar Water. David's traveled over 60 countries, introducing innovative new technologies, including broadband in the Caribbean in 2005. That had to be interesting. Along his ways, he's met a lot of prime ministers in the world, including 3 from the UK, 2 from Jamaica, Jordan, China, and Barbados. And in 1984, he received the royal warrant by His Royal Highness the Prince of Wales, who is now King Charles III. So, David, we look forward to your presentation.
Good afternoon. I apologize for my accent. Right. I'm from the UK, so I don't speak proper English. Time is of the essence. It's not an opportunity, it's an obligation to change the world. In 1896, don't worry, it's not a history lesson, right? But I'll just start with, in 1896, there was a Swedish scientist called Svante Arrhenius, and he discovered global warming. That was 126 years ago, and we're still talking about it. Right? Let's have another conference. Yeah. So, sustainably solving the global water crisis whilst combating climate change. Solar Water PLC, the first 100% carbon emission-free, decentralized and scalable technology solution. Water is life. I've done a lot of work in the Middle East, and if you take a look at the Quran, their Bible, the first word in their first book, water is life. I'm not a water person. I've only been in the water industry 4 years, but it's wrong to say I'm not a water person. So in the moment I was born, I needed water. I won't share my age with you, right? But I've used water for a very long time, right? So we all need water. Water is life. Nothing grows, nothing gets made, nothing happens without water. So we are trying to solve this water problem by using a different and a new technology. I don't know very much about California, but this is what I gleaned, right, from newspapers, from TV, etc. So it would appear that you have a water crisis. I think there's 5 cities where water is monitored, right? It's been fueled by the climate crisis. As I mentioned, there's restrictions on water supply. It's impacting water availability in farming. The Colorado River is drying up. The state reservoirs are drying up. The governor seems to have decided that desalination can play a part, right? And as Mark mentioned about 6 weeks ago, some new decisions were made about desalination. I'm not very good with it's working, thank you. Green growth, water innovation. So these are some of the things that our technology can achieve. It's 100% carbon emission free. It's decentralized. It's self-contained. It can be 100% off-grid. It works for 24 hours, although it's solar powered. I'll try to explain that shortly. It's scaled up at from 6 to 60 million cubic meters per annum. I'm sorry I'm using cubic meters, not US gallons, but from Mr. Google, there's 264, right, US gallons in a cubic meter. So 60 million cubic meters is just over 15 trillion gallons. So I can produce that per annum. The 5th generation concentrator, that's our differentiator, and I'll explain a little more about that. We recognize in some parts of the world, money is difficult. Governments have numbers of priorities, and you can't just go in and demand $100 million or $200 million for this particular project. So we have project finance available, right? We have access to 1.2 billion US dollars, which enables us to project finance, which hopefully will speed up the decision-making process. Because I can build it, I can operate it, I can transfer it after 25 years. All you have to do is commit to buy the water that I produce. We'll satisfy and we'll agree the price, and we'll guarantee that price for 25 years. You can't guarantee a supermarket price for 25 hours. So I can guarantee the price of water for the next 25 years. We have less variable cost in a pricing model. By virtue, we do not consume, burn in any way, shape, a fossil fuel. Our source of fuel is free. We're quicker to build. We're less expensive to build, and we're less expensive to maintain. So we think we have quite a substantial offering with lots of benefit. Sorry, I can go back. Yeah. So we have 2 processes. One is thermal desalination and one is electrical. I'll explain what these circles are in a few slides coming up. These are 2 drawings of 2 of the plants that we are developing right in the Middle East. One is quite a small plant. This produces about 1,000 cubic meters of water per day. The one on the right, it produces about 20,000 cubic meters per day. I seem to have difficulty with this machine. Thank you. Water outputs and carbon mitigation. You can now, as a country, and therefore I'm assuming as a state, you can claim carbon credits back by saving and stopping emitting carbon dioxide. These are some of the countries that we are working in and some of the size of the projects. If you take that over a 25-year period, we will save these countries, therefore the planet, over 8.5 megatons of 8.5 million megatons of carbon dioxide. I was pleased to see that both from Mark and Juliana, the partnerships are vital. No one person, no one organization can do it alone. You have to have partnerships. You have to collaborate. You have to share, right? These are some of our partners. The Mazda Institute, they're based in UAE, right? Cranfield University, that's based in the UK. They are a global force in solar power. They work with NASA, right, with regards to some of the issues. We work with SPC, which is the Saudi Water Partnership Company. Saudi Arabia is the world's leading desalinator. It has 28 desalination plants and desalinates 22% of the world's desalinated water. So if you want to know something about desalination, they've been doing it for 40 years. What they don't know goes on the back of a postage stamp. So we work with them to understand some of the things that they've encountered and some of the pitfalls we can avoid. We work with Siemens, a global organization, and we get some of our power units and the SCADA system to control it. And we work with Bechtel, a very large American corporation, but we have to pipe and pump water. So why not go to one of the world's largest pump and pipe organizations? But we have several other partners. This is what a concentrator looks like. My wife calls them sunflowers. Right? It's about 12 meters in diameter and stands about 13 to 14 meters high. It moves on 2 axes. The sunflower plant moves like that. The base here goes like that. The Siemens computer system, it controls this from sunrise to sunset. So as the sun rises, the sun will strike. As the sun moves across, this follows it automatically. It can create up to 1200 degrees C down here. We have one of these where you can go and see it in operation. We put a meter square of stainless steel, which is about 2 inches thick, and we put it up there. We burn a hole in it in less than 2 minutes. That's the power that we can create. That power is then energized to make it operational for 24 hours. We use about 1/3 of the power during the day. We use about 1/3 of the power during the night. And the other 1/3 is, if required, we can sell that back to the grid, or because we can be off-grid, we're generating our own green electricity. We have 3 business models. One of the key words I've tried to introduce into our organization is flexibility. We don't have a procedure manual. We don't have a process manual. We're just here to try and solve a problem. You tell me what your problem is. I can anticipate what the need is. Let's collaborate and let's see if we can solve that particular problem. We have a pure sales agreement. Somebody wants to buy it. We can build it. And therefore, all the water that is produced is yours. Thank you. Good night. We have a build, operate, transfer model or a build, operate, own model. We also, in certain parts of the world, we have a license agreement. So we can sell our technology to an organization and they can have that territory and they can go out and do whatever there is with our support. As I mentioned, we have project finance in place. So we can go from 25 years to 30 years. The average cost, depending on the volume of water that you are requiring, is between 50 million and 350 million US dollars for the CapEx and OpEx. Struggling again. There's about 40 countries in our analysis where we can solve or help solve the water difficulty. It all depends on the DNI, the sun's power of the radiation. We have calculated where it's red and where it's orange, we can solve that particular problem. And there's about 40 countries, but that represents about 20% of the global population. Earlier this week, it was announced there's 8 billion people living on the planet. 1 billion people today have a water difficulty. Another billion people today have no water. They have to go and find it. And generally, it's a child that is sent out to find it. And they'd use a bucket and they bring that back. They don't know the quality of the water because it's generally drawn from a well or from a river or a lake. They don't know the impurities that are in that water. I always like to think about positivity regarding the problem that we're solving. But when you understand some of the statistics, that 4,100 children will die today and tomorrow and the day after because of lack of water. That's why I said in my open remarks, time is of the essence. We collectively have to do something, but we have to do something in a way and a manner that protects the planet, therefore protecting ourselves. People talk about saving the planet. I like about talking about saving us. The planet has been here for 4 billion years. We've been here for 7,000. In 7,000, we almost ruined it. So let's face up to facts, right? And let's do something about it together. The desal market opportunities, right? There's mature markets with aging and existing desal plant. So we can replace some of those. Right? There's new and early markets that we can address. How we approach the market at the moment is through government and water municipalities. Right? We speak to water ministers around the world. We understand what their problems are. Agriculture has become a major issue. Right? We have a project in Tunisia. Tunisia is a very large country in landmass, but very small in population. It only has about 12 million people. It got 70% of its grain from Ukraine. For the last 9 months, it's had no grain, therefore no bread. But the rest of the world was getting its grain from Ukraine. So the world had to go and find another place for its grain. What did that do? That put the price of grain up. So the government of Tunisia, from the president down, the Tunisians can grow dates, they can grow oranges, they can grow tomatoes. If it rains, but it hasn't rained for 3 years, they have arable land, but no water. We can deliver them the water from the Mediterranean and irrigate several square thousand kilometers of land, making Tunisia food secure. We'll create more water than is needed for the irrigation, so we'll also make them water secure. You look at key industrial sectors for opportunities, food and beverages. Right? A liter of Coke, we've all had one, we've all had several, right? It takes 2.5 liters of water to make a liter of Coke. Tourism, everybody likes to go on holiday, stay in a 5-star hotel, play golf, have our laundry done, have our bedding changed. Where do you get the water from? Urban development. The population, as we mentioned, has gone into 8 billion. The more people you have, the more houses you need. The more houses you need, the more jobs you need. We briefly talked about mining and mineral opportunities. We are talking to 5 mining companies in Chile. The mining process demands water. The chemical processing industry. Textiles. 4,000 gallons of water to make a pair of jeans. 1 gallon of water to grow one almond. California's got 80% of the world's almond production. Somebody told me earlier this week that the water sucked up for the almond trees in 1 year could supply Los Angeles for 3 years. So we have to consider what we're doing, what we're eating, why. The manufacture of a car, we all been told about electric cars, aren't they amazing, wonderful, great. Whether it's a diesel car, whether it's a petrol car or an electric car, it takes 45,000 gallons of water to make it. The whole process. So we have to be alert as to what and why we're using the water. We have the backing of the British government. That's the Saudi Arabian ambassador. That's the ambassador to Qatar in the top right. This was an advertising program that the Department of International Trade put across the GCC for us. And this gentleman here is Simon Penny. He's His Majesty's Trade Commissioner for the GCC, and he was witnessing me signing our raising of 200 million for sustainable water projects in the Middle East. You'll be pleased to know that the $200 million that we raised as part of the 1.2 billion is from the United States. That is me, finished. I thank you. I thank you for your patience and time. Thank you.
We have time for some questions. So again, if you would please state your name and affiliation and speak into the microphone so we can record you. Any questions from anyone? We wore you out, did we? Oh, Subir, I knew you were
I'm curious. My first question is to you. The solar concentrators you showed, they are Fresnel type of concentrators, or what's the technology there? They're not parabolic reflectors that are pointing
No,
to.
they are made of steel and aluminium.
And now
And we have 13 world patents on the technology.
Okay. So if a point temperature becomes 1200 Celsius at some core point, are you directly circulating water through that point, or are you circulating sodium sulfate solution, producing electricity?
I'm just using them to produce the power.
Okay.
That goes off to another treatment plant.
Okay.
Right? Now, we can go up to 1200 degrees, but we don't need it for desalination. We go up to about 600, right? But to demonstrate the feasibility and the capability, we can take it up to 1200. We have one particular project where it's not involved in the desalination of water. They just want the green electricity.
My big question about this is, so your approach is solar to heat to electricity to desalination, am I right? So how is this, what is the fluid that is convecting the heat to the thermal power plant? Is it molten salt? It is
Molten
sodium
salt
sulfate?
or rocks.
Got it.
Yeah.
Thanks.
Anybody else? Okay, well, thank you very much to all three of our speakers this afternoon. Very interesting conversation, covering a whole wide variety of topics.